Hello, my name is Alex Stevenson, and my project is on the synthesis of analgesic. So for the introduction, I want to go in a little bit of background on what analgesic is. Analgesic is a pain medicine that is used mainly to relieve arthritis pain. There are two main types of it. There are over-the-counter Tylenol and prescribed opioids. Angiotensin or Tylenol, the benefits of it is that they are generally safe and are the first choice for non-inflammatory pain relief. It's possible to get too much Tylenol that can damage the liver, and if it is taken with alcohol, it can also damage the liver. Opioids are a different story. The benefits are that they dull pain receptors and promote feelings of good pleasure. The body can, though, develop a tolerance to opioids, and that makes overdoses extremely possible, as well as addiction. Side effects are constipation, drowsiness, nausea, skin itching, and dry mouth. Now that we know the importance of analgesic, we'll want to know how to make it. One way of making it is to weigh out 1 gram of p-aminophenol into a flask and add 35 milliliters of water to dissolve it. We will then want to warm the p-aminophenol solution in a steam bath and add 2 milliliters of acetate anhydride and swirl the solution for 10 minutes. Cool the solution in an ice bath and swirl until crystallization begins and allow the solution to sit. Then we will filter with a Buchner funnel and a vacuum line. Rinse the crystals with cold water and an air dryer with a vacuum. Collect the crystals and weigh them. Then perform identification of melting point in IR. Here are a few pictures from the procedure. The top left is the steam bath, the top right is an ice bath, the bottom left is the funnel, and the bottom right is after I collected my crystals. Here are the results we had from our procedure. The amount of analgesic we got was 0.22 grams. The theoretical yield from the balance equation was 1.48 grams. The percent yield for those two numbers would be 14.9%. The melting point for the experimental or observed was 167.5 to 168.5 degrees Celsius. The expected was 168.8 degrees Celsius. The percent error was 0.77 to 0.178%. The IR would be a hydroxy group here and a amine group here and a double bond to oxygen there. So now it's time to discuss some of the results that I had. For percent yield, my percent yield was off as I only got 14.9% of what was expected. This could have been because I didn't scrape off enough analgesic from the filter paper, some being left in the beaker and not being measured. Some could still have been in solution, did not go through the filter paper. And it's also possible I did not heat my solution up enough in the steam bath. For the melting point, it's below 1%, the percent error was. It's extremely, extremely close with what I expected it to be. So I feel pretty good about the melting point part of the experiment. And my RR graph also came out really clean and is also extremely close to what was the expected result from online resources. So there's my IR. You can see peaks here as well as here. And now for the experiment's conclusion. I believe that my analgesic was extremely pure. I did not get a lot of it back, which is unfortunate. I believe a decent amount of it was left in the beaker, and I couldn't scrape it into my measuring plate. And also, I do think some of it was stuck in solution. I probably could have filtered it through a few more times, but I mean, it was a kind of a time crunch. So What I did get back, though, I do believe was extremely pure, mostly just because the melting point being so close to expected, as well as the IR being uh, as good as it was. Um, the reflection for me is just being able to work on my own and, going through and setting up my own experiment basically with outside resources and being able to, um, and that instilled confidence in me. Uh, I still believe that I need to work a little bit on my own, being by myself in lab and not asking so many questions. I just need to be confident and to know what I'm doing is right. And there are my citations.